Hello, hi. This is analysis of algorithms, part 5. Again, we have another example of finding number of spanning trees in this class. Uh, we will try to calculate the number of spanning trees in a square grid network, of course, using the approach or the method of Kirchhoff matrix tree theorem. So a graph, in undirected graph, we try to get a number of spanning trees for that graph. So we could have n minus 1, n is number of nodes, minus 1, n minus 1 edges for each spanning tree. So 3 minus 1, if we have 4 nodes, minus 1, you will get 3 edges. So that is the graph that we have, 1 to 2, 1 to 3, 1 to 4. And there's also, there are four nodes, and we try to have spines with no cycles. So this is a cycle right now, that's a cycle right now. So here we try to build up Laplacian matrix L, which is equal to D degree matrix. So in degree matrix, we count connection at each node. Okay, for example, in node 1, node 1 is connected to 2 and connected to 3 and connected to 4. So it has 3 connections. And node 2, it is connected to 1 and 3. And node 4 connected to 1 and 3. And 3 connected to 2, to 1 and 3 and 4. So 3 has 3 connections and 1 has 3 connections, 2 has only 2 connections, and 4 has 2 connections. What we mean by connections, direct connections, okay? So that is degree matrix A. It has 3 connections, node 1. So node 1 has 3 connections, node 2 has 2 connections, this and this. Node 3 has 3 connections, this one, and this one. And node 4 has 2 connections, this one and this one. Now, that is the degree matrix is done. Now we try to get adjacent matrix. Adjacent matrix means that A is connected to 2, to 3, to 4. So to 2, 1, to 3 is 1, to 4 is 1, but to itself is not connected. Likewise, node 2 is not connected to itself, and so but it's connected to 1. It's not connected to itself, that's 0, but it's connected to 1, that's 1, and connected to 3, that is 1, but is not connected to 4. There is no connection to 4. If we take 4, that is 4, not connected to itself, but it's connected to 3. That's 1. It's connected to 1. That's 1, but it's not connected to 2. So on and so forth. So now this D minus A, we will get element-wise subtraction. So 3 minus 0, 3 minus 0, 3, 0 minus 1, 0, 0 minus 1, minus 1, 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 and so on and so forth. So we found the Laplacian. Now, to do Kirchhoff, we will remove row 4, this row, in L matrix, and we remove this one. So remove the column, and we remove row 4 and column 4. So we will have this matrix right now. That is the determinant. So in the determinant, then we go by each term, term 1, term 2, term 3, next step. So if we go by term 1, first term, so 3, and we take the minor is this one. So 2 multiplied by 3 minus 1 multiplied by minus 1. So here we will have 2 multiplied by 3 minus 1 multiplied. So 2 multiplied by 3 minus 1. So we will have 5. Multiplied by 3. Why this 3? It is here the determinant. So multiply by 3. Now for the second term, we will come to this one, second term. So we ignore this and we ignore this. So we'll take this one and this one. So we'll take minus 1, minus 1, minus 1, 3. So this multiplied by this and this multiplied by this, and minus 1 multiplied by 3, minus 3, minus 1 multiplied by minus 1, that is plus 1, minus 1, so 3, minus 3, minus 1, minus 4, multiplied by minus 1, which is the second term, that's normal, so it will be minus 1 multiplied by minus 4, 4. And this is the contribution. The minus sign is the contribution for the second term. It will be added, so it's minus 4. Next, we move to here, this part, minus 1, term 3, third term, minus 1. Again, for the term 3, this will be neglected, this will be neglected, so we'll take this part only. That's the minor. So the minor is minus 1, 2, minus 1, minus 1, minus 1 multiplied by minus 1, minus 1 multiplied by 2. So then minus 1 multiplied by minus 1, that's 1. Minus 1 multiplied by 2, 2, minus it, minus plus 2, 1 plus 2, 3, multiplied by minus 1, because that green I indicated, so that's for that. So minus 1, the results of the output of the minor multiplied by its term, which is the third term. So that's 8. Now we calculate 8 added to minus 4 and 15. So 15 plus 8 plus minus 4. So let's do it. 15 minus 4 minus 3. So 15, that's 15 for first term. And for the second term, 4, 15 minus 4. And for third term is minus 3. So 15 minus 4 minus 3. So 15 minus 4, 11 minus 3, 8. So 8 spanning trees we have. The first spanning tree, second spanning tree, third spanning tree, fourth, fifth, sixth, seventh, 8. So 8 spanning tree. Thank you very much. That's the basic calculation, how we can find the possibilities of spanning trees in a graph. If you have any further information you needed, please check those my website and my YouTube channel. Stay tuned and thank you very much. Take care.